Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. Today we continue with our more heterocyclic compounds, namely pyrazole, imidazole, oxazole and thiazole. For 5-member ring heterocyclic compound on which ring is composed of carbon, nitrogen and one other heteroatom are also known as azoles. One more heteroatoms are also named as azoles. There are three types of azoles depending on the second heteroatoms. Second heteroatoms may be nitrogen, oxygen and sulfur. As for example, we see if pyrazoles, then it contains two nitroatom, nitro as a heteroatom. Therefore, in pyrazoles there are number of carbon is 3 and nitrogen are 2. They are known as pyrazoles. And second one, oxazoles. So they containing carbon 3. They have 3 carbon atom, 1 nitrogen atom and oxazole have 1 oxygen atom in their ring structure. So oxazole containing 1 nitrogen, 1 oxygen as a heteroatom. And third one is thiazoles. So they contain 3 carbon atoms, 1 nitrogen atom and 1 sulfur atom. According to our previous lecture, we see 5-member ring heterocyclic compound pyrrole, furan and thiophene. Pyrrole contains 1 nitroatom as heteroatom. Furan contains 1 oxygen and thiophene contains 1 sulfur as a heteroatom. But today we discuss one more heteroatom. So these are coming from 5-member ring, 2 or more heteroatoms, simple and fused compound. So 5-member heterocyclic compound in which ring is composed of carbon, nitrogen and one other heteroatom are also named as azoles. As for example, pyrazoles, oxazoles, thiazoles. There are 3 types of azoles depending on the nature of second heteroatom. If there is a second heteroatom, one heteroatom nitrogen and also one nitrogen, so it is pyrazole. One nitrogen, one oxygen, that is oxazole. One nitrogen and one sulfur, that is thiazoles. Thus, pyrazoles, oxazoles and thiazoles may be derived from pyrrole, furan and thiophene. By replacing methane group with nitro atom. Methane group with nitro atom. So we see these groups one by one. First of all, we see pyrazole group, and pyrazole group are combined with pyrazole and imidazole. Pyrazole and imidazole. Two position coupled with nitrogen known as pyrazole. If in pyrazole, if the compound, this is pyrrole, This is pyrrole. And if here one nitrogen present, one more nitrogen as a heteroatom, therefore it is two compound, two heteroatom. So two position, that is number 2. 1, 2, 3, 4 and 5. So two position coupled with nitrogen as heteroatom are known as pyrazole. This is pyrazole. And while nitrogen is attached in 3 position or beta position, if second heteroatom is at 1, 2 and 3 position, then it is known as imidazole. Imidazole. It is also known as imidazole. And also it is known as glyoxaline. Glyoxaline. So first of all we see pyrazole and then imidazole, and in next lecture oxazole and thiazole. So first of all we start with pyrazole. Structure, this is pyrazole. So two position coupled with nitrogen as heteroatom, and it contains two nitrogen as a heteroatom. So it is 5 member, 2 or more hetero compound containing simple heterocyclic compound pyrazole. First of all, we see preparation of pyrazole. By passing acetylene into cold ethereal solution of diazomethane. Diazomethane. Cold solution, ethereal solution of diazomethane. First preparation, acetylene, CH triple bond CH. This is acetylene. And cold ethereal solution, CH2 N double bond N. This is cold ethereal solution of diazomethane. Diazomethane. And this is acetylene. Presence of ether, it converts into pyrazole. Pyrazole. Second preparation, propylaldehyde, CH triple bond CCHO. It is Propagraldehyde is treated with diazomethane. 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 Then it is known as 3-formyl pyrazole. 3-formyl pyrazole. So, by passing acetylene into cold ethyl solution, we get pyrazole. Now we see more preparation. Number 3, condensation of hydrazine. Condensation of hydrazine with beta dicarbonyl compound. With beta dicarbonyl compound. I write down first beta dicarbonyl compound. This is beta dicarbonyl compound. Beta dicarbonyl compound. Treated with hydrazine. Hydrazine. So, we get CH3CH3. So, number 1, 2, 3, 4 and 5. 3,5 dimethyl pyrazole. 3,5 dimethyl pyrazole. Acetoacetic ester react with number 4. Acetoacetic ester CH2 CH3 C double bond O C double bond O C2H5. Acetoacetic ester treated with phenylhydrazine. Here we have hydrazine. This is phenylhydrazine. It is converted into C6H5 CH3, and fifth position contains C double bond O. So this is 1-phenyl 1, 2, 3, 4 and 5. 1 phenyl, 3 methyl, 5 pyrazolone, that is pyrazolone. Pyrazolone, Zolone. This is 1 phenyl, 3 methyl pyrazolone. Now we see two more preparation for pyrazole. Number 5, pyrazole 3,4,5 tricarboxylic acid. Pyrazole 3, 4 and 5 tricarboxylic acid undergone by decarboxylation at 300 degrees Celsius. It converts into pyrazole. This is pyrazole 3, 4, 5 tricarboxylic acid, and this is pyrazole. And last, number 6, glycerin, CH bond CHO double bond CH2. This is glycerine, is treated with hydrazine. This is not glycerine, it is acrolein. By mistake, CH double bond CH2 CHO is acrolein. ACROLILEIN, acrolein, is treated with hydrazine. First of all, it converts into acrylaldehyde hydrazone. Acrylaldehyde hydrazone. This is acrylaldehyde hydrazone. And now cyclization takes place, then it is converted into pyrazolene. This is pyrazolene. So these are the preparation of pyrazole. Now we see properties of pyrazole. Pyrazole is colorless solid with melting point 70 degrees Celsius. MP is 70 degrees Celsius and boiling point is 185 degrees Celsius. Colorless solid with melting point 70 degree and boiling point 185 degree Celsius. It is basic and forms salts and is secondary base, gives substitution reaction substitution reactions. Pyrazole is a tautomeric substance and so the position 3 and 5 must be identical. Tautomeric compound, I write down structure for tautomeric. So pyrazole is tautomeric. So when representation of pyrazole, that's position number 3 and 5 must be identical. Here we write down 1, 2, 3, 4 and 5. Here 1, 2, 3, 4 and 5. So when position 3 and 5 must be identical. So it is very important for pyrazole. Pyrazole is a tautomeric substance and so the position 3 and 5 must be identical. And intermolecular H bond is formed between 2 moles of pyrazole to form dimer. I write down further the structure of pyrazole for H bond. This is 2 mole of pyrazole. And intermolecular bond, there are intermolecular bond from this compound and this compound, hydrogen and nitrogen, this hydrogen and this nitrogen. So an intermolecular H bond is formed between 2 moles of pyrazole to form dimer. This is dimer. Now we see resonance structure of pyrazole. Resonance structure of pyrazole. This is the resonance structure of pyrazole. Unpaired electron described here. So resonance structure of pyrazole. Now we see important chemical properties. Due to this resonance structure, the halogenation, nitration and sulfonation, the group enters at position 4. Enters at position 4 due to a larger pi electron density on carbon 4 than on any of the other molecular carbon atoms. Any other molecular carbon atoms. So when halogenation, nitration and sulfonation takes place, The position for this group enters. We see by this chemical reaction due to larger pi bond electron density when halogenation takes place. Halogenation, nitration, and sulfonation. The fourth position enters the group from fourth position. Halo group. For halo compound, if bromine is present, then 4-bromopyrazole, 4-chloropyrazole, 4-iodopyrazole. Nitration takes place, then 4-nitropyrazole and sulfonation takes place. Then pyrazole 4-sulfonic acid is obtained. On acetylation of pyrazole, if we takes place acetylation, then 1-acetyl pyrazole here hydrogen is substituted and acetyl group enters, therefore 1-acetyl pyrazole is obtained. And if benzoylation takes place, then N-benzoyl pyrazole is obtained. N-benzoyl pyrazole is obtained. If we takes place reduction, catalytic reduction, then pyrazolene and further reduction takes place. Then pyrazolene. This is pyrazolene. And further reduction, then it is converted into pyrazolidine. So with the help of reduction, it converts into pyrazolidine. So these are the basic chemical properties of pyrazole. Pyrazole is also give azodine. So if we see here more for reaction, if we have a 4-nitro, this nitro derivative, if pyrazole give nitration, so it gives 4-nitropyrazole, and with the help of reduction, it takes place reduction of 4-nitropyrazole, then it convert into 4-aminopyrazole, NH2, and this compound gives azodine taste when we treated with NaNO2 plus HCl. then it is converted into diazonium salt of pyrazole. NH2 is converted into N double bond and Cl. N double bond and Cl. And this compound is treated with coupling material beta naphthol. We have structure beta naphthol. Beta naphthol in NaOH. Beta naphthol is dissolved in NaOH and takes place coupling and maintain 0 to 5 degree Celsius temperature. Maintain 0 to 5 degree Celsius temperature. Then it gives azodize. It gives azodize. It gives azodize. This is our coupler material. So pyrazole is very important for preparation of dyes. This is well known example of azodize which is prepared from pyrazole. Today we stop our lecture here and remaining compound we will see in next lecture. Okay, thank you.